Bears are large mammals of the order Carnivora, yet they are omnivorous rather than strictly predatory. Their evolutionary path favored versatility, powerful jaws, well-developed molars, strong limbs, and relatively high cognitive abilities. This combination allowed bears to successfully colonize a wide range of ecosystems, from Arctic tundra to temperate forests and even subtropical regions. The surface area of the olfactory epithelium is several times larger than in humans. The olfactory bulbs in the brain are highly developed. A bear is capable of detecting food from distances of several kilometers, remembering food sources for years, distinguishing familiar scents from new ones. For this reason, bears display complex behavior. They plan movement routes, return to successful feeding sites, and are able to adapt to changes in their environment. The bear is a classic example of seasonal adaptation. In spring and summer, it feeds on plants, berries and nuts, insects and their larvae, fish, and small vertebrates. In autumn, a period of hyperphagia begins. A bear may consume up to 15,000 to 20,000 kilocalories per day, accumulating fat. This fat is not merely an energy reserve, but a vital organ that provides thermal insulation, hormonal balance, energy supply to the brain and heart during winter. An adult bear can reach speeds of 50 to 60 kilometers per hour over short distances. This is made possible by a large proportion of fast-twitch muscle fibers, powerful hind limbs, elastic tendons that efficiently store and release energy. At the same time, bears are strong swimmers and can cross rivers and lakes over long distances while expending relatively little energy. Bear hibernation is one of the most fascinating phenomena in mammalian physiology. During hibernation, heart rate decreases from approximately 40 to 50 to 8 to 10 beats per minute. Body temperature drops moderately, usually by 3 to 5 degrees Celsius. Breathing becomes slow and shallow. Importantly, the bear does not eat, drink, or defecate for up to 5 to 7 months. At the same time, it does not die from intoxication by metabolic waste products. Instead, its body recycles waste back into useful substances. Urea, for example, is reused for the synthesis of amino acids. Why does the bear not lose muscle mass? In humans, prolonged immobility leads to rapid muscle atrophy. In bears, the opposite occurs. This is due to active recycling of nitrogen and proteins, constant microcontractions of muscles even during sleep, specialized hormonal regulation. As a result, the bear emerges from the den with little to no loss of muscle mass or strength. This phenomenon is actively studied in medicine, particularly for the treatment of muscle atrophy and the effects of long-term immobilization in humans. During seasonal salmon runs, brown bears actively concentrate around rivers and streams. They use shallow sections, rapids, and narrow channels where fish are forced to move upstream against the current. Bears rely on a combination of vision, hearing, and precise timing to catch salmon with their jaws or forepaws. Salmon are an extremely important food source because they are rich in fats and proteins. Consuming large amounts of salmon allows bears to rapidly accumulate energy reserves that are crucial for survival during hibernation. In some populations, access to salmon significantly influences body size, reproductive success, and cub survival. The female brown bear raises her cubs alone. Males not only do not help, but can also pose a danger to the cubs. For this reason, the mother avoids adult males and aggressively defends her young until they are fully grown. The brown bear is not just a symbol of strength. It is the result of millions of years of evolution, an animal that combines power, intelligence, and physiological efficiency. From salmon-filled rivers to winter dens, every aspect of its life is precisely adapted to survival in a changing environment.